In this lesson, we will consider strategies on selecting a correct distribution for inferences on the population mean. And our two choices will be either Z or T distribution. Suppose that we want to estimate the mean cholesterol level in adults aged 55 or more. We choose a random sample of such levels. The random sample we choose has a mean of 196.5 milligrams per deciliter and a standard deviation of 20 milligrams per deciliter. For each of the following sampling scenarios, determine which test statistic is appropriate to use when making inference statements about the population mean. Scenario 1. The sample has size 110 and it is from a non-normally distributed population with a known standard deviation of 19.1. I provided you here with two ways to summarize this information, and I have to tell you sometimes it is pretty hard to make the right choice, and sometimes there's more than one right choice, so we have to be careful. In this case, we can see that the sample size is large and sigma is known. Those two are very important factors that point towards Z, because Z must have standard deviation with the population known and a large sample size is required. Well, whether it's normal or not, if it's normal, great. If it's not, if sample size is large enough, the distribution of that sample will be approximately normally distributed, so Z is appropriate in this case as well. And our sample size is 110, which is pretty big and fits this description. So we are going to choose Z. The sample has size 75 and it is from a non-normally distributed population. So in this case, we know that there is no normal distribution, but sample size is large. However, we don't know much about whether the standard deviation of the population is known or not. So we're going to say it could be either Z or T, depending whether we know sigma or S. Next scenario. The sample has size 20, and it is from a population with a distribution about which we know very little. We cannot go and make a decision based on a small sample size and nothing else known, so we are going to say it is unclear. Scenario number 4. The sample size is 16 and it is from a normally distributed population with a known standard deviation. Small sample size, unknown sigma, but normally distributed population points towards T, because if I have a sample I can always compute S, and normality is there to allow me to use even a small sample. So this time we choose T. Last scenario, the sample has size 12 and it is from a normally distributed population with a known standard deviation of 19.1. If we have normally distributed population with a spelled out sigma, sample size 12 is not preventing us from going with a Z choice. Although Z or T could be chosen, Z probably is good because we have sigma. That sigma is a very important factor in this case, in addition to the normality of that population. Let's take a look at one more example. Suppose that we want to estimate the mean germination time of strawberry seeds. The germination times for the sample of strawberries we choose has a mean of 16 days and a standard deviation of 1.5 days. For each of the following scenarios, determine which test statistic is appropriate to use when making inference statements about the population mean. Scenario number 1, the sample size is 95 and it is from a non-normally distributed population. Large sample size allows me to compute S, and with large sample size, even without a normal distribution, we still can use T or even Z because of an extremely large size. So 95 is a big size. The sample size is 15 and it is from a normally distributed population with unknown standard deviation. Small sample size, normality of the distribution, but unknown population standard deviation. Well, that fits into a T description. How do I know? Small sample size, normality is okay, And from that sample, I can always compute S. Next scenario, the sample size is 12, and it is from a population with a distribution about which we know very little. We need more information to make a decision, so this time we again choose unclear. The sample size 17, and it is from a normally distributed population with a known standard deviation of 1.3. One of the main things to pay attention to is sigma is known, and normality of the distribution is known. Sample size, even though small, is not a problem. With these two things known, I can go with Z. Last scenario, the sample size is 85, and it is from a non-normally distributed population with known standard deviation. Again, known standard deviation, sigma, and large sample size does not prevent us from using Z, because even with a non-normally distributed population, the large sample size allows for the approximate normality with the sample, so we can go with Z.